All right. Welcome to a very late episode 3. So I've got my hoodie on. I've got dark light on, and I'm doing my thing. So I thought I'd tackle a few things. I'll do like a low key episode 3, tackle a few items that I want to tackle. We'll see how far we make it here. There's a few things to go over. Let me switch my... All right. So in episode 2, we went over essentially how our data is going to be stored. It's going to be arrays. We went over how we're going to call the data, set up the data, manipulate the data, things like that. I have a few things that I need to tackle. So the first thing that jumps to my mind is, well, obviously I have to clean up this code, but I need some more. I need a few more things here. So I need to clean up the error handling. I don't 100% like the way this turned out, but it's good enough for episode 2. But for episode 3, it's not quite good enough, because in episode 3, we're going to take this to the next level. So we're going to clean this up. The other thing I'm realizing is that I also would like to have a way to dump out arrays that I create, so that like this, for example, and then load them in and build them as part of the WebAssembly file, much like we did with SIG. The reason why is it's going to be a lot easier for me to contain individual array blocks for specific things rather than keeping them all here. So I think I have a way to do that, at least to get the ball rolling and make our lives just a touch easier. So I'm going to try and figure that out. So before I do anything else, what I need to do is I need to clean this up a bit. So we're going to echo out here. I'll zoom in. Building the game via ODIN WSL Windows. This build script is it's wonky to me, so don't take it as like, this is the way it should be done for you. It's just because of the way that I've set up my local environment. So we're going to set up an ODIN path, and then that way I should be able to just reference that here. So this is a bash shell script. Yeah. And then we can kind of go like that. And then we can go like this. So the slash at the end here just tells bash that there's a new line, and it treats it all as a single command. Okay. I think that's adequate. So here we can just put something out at the end. Echo built game. All right. So if I'm going to clean this up, I'm going to have to essentially like comment out a bunch of stuff that we did, because it's all over the place. So I'm going to comment all this stuff out. We'll leave it here because it's good to have notes on what we did. All right. Okay. Yep. Good. Okay. All right, to start with, what I'd like to do is I would like to restructure the logging here and take this out, and I'd like to put it in its own file. And I think in order to do that, Odin has the ability to use something like it would be called packages. And as long as you have the same package name, so package main in my case, so you do this, and then you'd save it. It'd be logging.odin. And so in this case, when it builds the current directory, it'll look for all the .odin files in the current directory, and as long as the package name is consistent, it will put it all together. So I generally remember the idea from the logging from before. We want like 100 messages, and then we want codes. It should be pretty easy. It's just code. So we can set up max messages here. And it would be, 100, and then log messages would be the max messages, but in int format. Here's another thing. I looked up the difference between like U16 and I32, U32. I was thinking that U16 would give us just a little bit more performance because it's a smaller set of available integers that you're using. What it really does is it gives you a smaller set of memory space. So if you're only going to use like the max of U16, which is 65535, 65,535 different values, then it does take up less space per value. But the problem is that a lot of CPUs these days are have extra tricks and performance gains, and I think GPUs as well, for 32 and 64. So because we have access to 32, I'm going to switch everything over to 32, which does kind of make things a little bit nicer. It gives us more integer room, like ceiling room to work with, so there's more values there to work with per entry, like per integer. And it also makes it easy. We just call int everywhere, so that's nice. It's a much easier definition. I want to know how many I have, how many log messages I have in my array, and I initialize it at 0. I want to have an enum that has like codes, so it'd be like 0 would be message code.empty would be 0. Error. I know we have reserved values, and then I know we'll have a general, and maybe we'll add some more. And then I'm going to want to like take the enum value and convert it to an integer. So it'd be like convert message code. And then the proc would be code message code, and then int, and so so if we define that this is message code, then essentially what we're doing is we're kind of like typing, making sure that message code is what we're passing to this function. We convert it directly to an integer. We set the max to max of integer. So this would be, so for example, U16 would be 65535. That would be the max, right? So we set it, and then what we're going to do is we're going to return whatever the max is minus the converted code. What that does is imagine that, so let's say we had U16 because it's easy. We're at the very top. The very top is 65535. This is 0. So message code.empty gets converted to 0. 65535 minus 0 is 65535. And then 1 would be this. Message code.error reserved value would get converted to 1. Max 65535 minus 1 would be 65534, etc. what we're doing is we're essentially reserving the top section of our integer, which is whatever it is, I32, whatever, and whatever Odin decides here. And we're just saying that those are reserved values. We can't be using those when we're storing values elsewhere. And it means that we're going to have to check. So we're going to have to check that these values are not, like values that we're storing somewhere are not reserved, right? So we're going to go for all the enum entries in message code, if convert message code log code is equal to the value we're checking for, then we're going to add a log message, which we're going to define. And it's in this case because we're going to type it to message code, so we should be able to just do error reserve value because it'll just automatically determine that it's part of that enum. And then we'll have to export add log message, and that will also be a, so we'll do message here, we'll do message code, we'll add a should panic. Should panic just kind of like it essentially just causes the whole application to just completely like throw up. It's optional. Sometimes we want it, sometimes we do, and we can initialize it like this. We can say true or false. In this case, I guess it would be false. So we're gonna receive it. We're gonna go. You shouldn't be adding a message if it's greater than max messages. We made a mistake here, right? And so if you do that, no, if you're adding, okay, yeah, I got it. So if you're adding a log message and you've already hit the maximum number of messages, what you want to do is you want to take off the top, like take the oldest message, remove it, move everything up, and that frees up the space on the bottom. Well, for the it would be first in, last out, and so it would become this message would be the most recent message. So if we do that, then what we're going to have to do is I guess we'd have to go in this, and because we're an off by 1, so we're going to have to go -1. So for the curve, so from 0 to max messages -1, from 0 to 99, I becomes whatever the current value is. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and whatever, blah, 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 blah. And then we're going to go I is equal to +1, right? Yeah, okay. So if we're at 0, we go grab 1 and we make it 0, and so on and so forth. Okay, this is how we're going to do it. And then simply put, you're just going to go well, here, what you're going to do is go max messages -1. So we're just going to update the log count just to be sure at this point that we're fine. Log messages, log, we can just use log count. Yeah, we can just use that's right. We can just use log count, and then we can just put in the converted message code right in there, and that just becomes your code. And then we just iterate the count like that. And now we want to do the panic. So if we're gonna do this, then you'd think you should be able to do that, but what you have to do in this case with Odin is you just have to say if it exists, if should panic exists, and it's true, then we're gonna panic. Yeah, okay. And then we're gonna want to read. Right, so what we need to do is we want to go and at a particular point in the array, we can define which one we want to see. We're going to go index int, and then we're going to pull the integer value that's stored in that whatever it is. Now, if your index is greater than the log count, then you've exceeded. Okay, so we're just going to typecast it, and if it's greater than well, log count is, yeah, so log count might be off by 1, so maybe let's just make sure. No, it wouldn't be. So we're okay. So we're going to go, if you're trying to read from something that's greater than the number of messages in there, then no, what you're going to do is you're going to return nothing. That's what you're going to do. It's going to return nothing for just a 0. But then what you can also do is you can add a log message, and then you can just do like a true with a should panic. And if not, then what you're going to be able to do is return log messages index. Okay, and then what you're going to want to do is also have clear all log messages, yeah? And then it's just going to go through and just set them all to 0, I believe. Yeah, that makes sense. Okay, so in 0 to max messages -1. No, it's not -1 because we want to go right to the end. That's what we want to be doing. We're going to go log messages I equals 0, and then we'll have to reset the count 0 of log count. Okay. Now, if I've done this right, then what I should be able to do is just remove this. And let me pull up my shell. Okay. Here. Go in. We'll go in here, and then we'll go ODIN, and then we'll go build. Okay. So we've got a problem. It did actually pull. Well, first of all, I've spelled it wrong, so let's fix that. It did actually pull the correct. It worked. So like essentially now, I have access to the functions in logging. In here, it's packaged up, it's all packaged up together. Right. I've of course typoed that. Let's go see what else there is. Undeclared name is code. Did I not change it? There we go. So there's code here. So where is the code? 38, line 38, huh? I guess this would be message. Undeclared some array in game. Okay, so then the rest of the stuff is in game. So you know what? Let's also take all this out. We don't need it. All right, cool. Okay, that's great. Now we need to do something else. It would be nice if instead of storing these here, if we were able to store them, say, in their own files. So let's try and do a new file, and we're going to call it enums. Okay, and that's it. Let's see if that works. It seems to work. Now what we're going to try and do is we're going to try and initialize. Well, actually, we have a perfect candidate here. We'll just go, let's just pretend that these are the ships we're going to have. Okay, now at this point, yeah, At this point, what I would like to be able to do is optionally take any array and essentially just dump it out into a file. So like a binary file, much like I'm going to do on the JavaScript side. We did it with WebAssembly before, and it will dump it out so that I can take it in like and embed it essentially. So we're going to have to do more or less, we're going to have to do two things. First, let's try and get something that like dumps out the file. So I know that in order to do this, there's a build process, like there's a build configuration that you can set up. I'm saying that wrong. You can have ODIN read in build configuration values, custom ones, and then operate on those values in a particular way. We're compiling to WebAssembly. That means that we're going to have an entry point that's like the main entry point, and we're going to actually have to run the ODIN file instead of compiling it to WebAssembly, as in it will not get compiled to WebAssembly. So we need to have a flag that we can read in this WebAssembly file. It has to read the array that's in the WebAssembly file, but then based on the configuration flag from the build script, dump the array out to a binary file. So I'm going to try and get and kind of demonstrate what I mean. So I know that you can do something like you'd have to set it to a constant, and you can use the hash config, right? And so it'd be dump array. So it's just going to be whatever. We'll just go game ships array. It's just a way to do it, right? And then we're going to need a function. We might put this in its own. File. But anyways, so it'd be like dump array to file. Okay, so that's the array that we're going to pass in. We're going to want to name it something. Okay, and then we're going to return whether it's true or not. We're going to need the data, which we have to allocate, which means we're going to have to make some memory, and it has to be in byte form, I believe, because when you're writing to a file, you want to write the bytes out. It's a pretty raw way to write to a file, but I think that's what we need. So I think it's this, and then we're going to take the length of the array, and we're going to oh boy, we're going to multiply it by the size of whatever int is, right? Because an array, it's an array of int, and so we're gonna take every array. That's right. That's exactly what we're doing. We're taking every array value and we're saying what is its maximum size. So whatever. So in U16 it'd be 65535, and we're just multiplying the two, and then we're creating an array of bytes equivalent to that. And then what we're going to have to do is go through the data and essentially copy over the value of the array of the game array into the byte array. So let's say we did in R via, no, it'd have to be like this. Value. V would stand for value and I would stand for index. Mem.copy, and then I think it takes 3 values, which would be V. So value size of int. You know what? Let me see if I can. Yeah, I'll put it on screen. So mem copy, is it in here? Yeah, I don't see it. Let's go to the GitHub and let's have a look. Okay. So essentially it's something along these lines. mem.copy. There's a buffer. There's a value. And then there's a size. Okay. So that means that we'd have to take the value. We probably have to have a pointer to the value. The size is correct, but this, oh, it's where you want to write to. That's what it is. So you'd want to write to whatever the new data array that we've allocated, and it'd be the index times the value, like the size of, sorry, not the value, the size of integer. And I think because it's technically a buffer, we probably need to point to it. Yeah, it looks like we have to point to it as well. We have to pass by reference. Okay, so at the index of whatever this is in the data array, we're going to pass the value of the game ships array, and the size of the value is going to be the size of int. I'm not sure that's going to work, but we're going to give that a shot. And then essentially we're going to man, I don't think they have a lot of there's write file, but let's make sure. So there's seek, there's read, there's write, there's read at, write at. But I want to right. Okay, this isn't quite right. I don't think we. This is more like specific to the operating system when you write a file. And I think there's a generic way where Odin just kind of figures it out for you. I'm just gonna go have a look here. File Windows OS. Oh yeah, here we go. Write entire, write entire file or write entire file ERR. And essentially, yeah, see here, it's going to take care of operating system stuff for us. So this, okay, perfect. So we're going to go OS write entire file, and it's going to be name data truncate. So we're going to go file name, and then it's going to be array. I'm pretty sure. Okay, so there we go. That was a lot of work for a thing. Now what we need to do is we have to take a like an entry point, so a main function. It's going to be like that, and then we have to determine when dump array is flagged true. We're going to go if right? Yeah. Okay. So we go. So we're gonna go check and make sure that we can actually write this array. So we'll go like this, and then we'll call it gameships array.bin, and then we just you know what? No, we have to pass the entirety of the array, and I think you do it this way. I think you do it that way. Append a slice. Take the whole slice, right? Yep. Take the whole slice. That's how you do it. Yeah. That's the whole thing. Yeah. Okay. So you do the whole thing there, and then we can do just like, because it's in, normally this format print wouldn't get printed in WebAssembly mode. But because we're going to be running this, it just like instant run and then exit out, then we can do, we can print out to the console so we can see what we're doing. I think there's a way to print errors. There's T print line. Okay. Let's go search for print line. Oh, perfect. Formats using the default print settings and writes to stder. Perfect. Those STDs. Could not write file. Okay. And then at this point, we just like want to exit, because if we're gonna run this, like we need to exit. Okay. If this is right, then I should be able to copy this, and instead of running the WASM output, I can just run like something like that. And essentially what that should do is tell the Odin build that I want to do the dump array operation. Let me make sure I'm using this correctly. Config defines it. Oh yeah, you got to do define here. Okay, glad I checked. All right, now if I do that and I run it, it will fail. Okay. Why did it fail? Because I don't have a comma here. Let's try this. Okay, why did that fail? Expected that, got when. Oh, I keep doing that. All right. Of course, I have to import core mem. I have to import core OS. I have to import core FMT, I believe. And I probably have to import runtime, but I'm not sure. So what is the problem here? The problem here is non-procedure data of type U8. Cannot call a non-procedure. Oh. Right. I wrapped it in a bracket, so it thinks it's a function. That's not going to work. We need to wrap it in square brackets. That is the index that we want to write to. Can I assign array? Nope, because of course not. We want to put data in there. Okay, there we go. Did it work? We have to run it. There we go, file written. Okay, now if I look in this file, oh yeah, it worked. So here's the deal. You can see that the values worked. Even if you just take these values in rows and columns, have a look at what we did here. We went 110, 210, 330, 410, 510, right? So if you look at it, you can see 1, 10, 2, 10, right? And then 3 and 30. And so these are the hexadecimal values, essentially. This is just the way Sublime opens it. They could be opened in a variety of other ways. And these things take up 32 bits, I believe, in this case. I think Odin goes up to 32 bits. So essentially you can just like imagine that, that's the space that they take up in here. Each hexadecimal value being 4 bits, I suppose. So I guess it'd be 4 by 4 plus 4 by 4. So I guess each 32 is like one of these. And then another 32. And then another 32. I'm pretty sure that's how it works. Don't quote me on that. But yeah, but we can see the values are in here, and that's great. So now what I should be able to do is, what if I want to pull this in now? I want to use it. So instead of game ships array, I don't want to be building like a big array value here. I'd rather dynamically generate some arrays and then pull them in, like embed them as files and read them. So if we go back here, there is a load, and you can load a file here. It returns a U8 of file contents at compile time, or as another type if you want to pass it in as a string, but we're okay with that. And then we should just be able to read it and pick any index and write it, I guess. So if we were to do that, what we could do is go game ships file load game ships array.bin. Let's do it as an int, and it'd be like this, right? Yep. And then we would go format print line value at whatever. And so game ships file so what we're going to do is we're going to just pick a random index. So if, let's say we went like, so it'd be 0, 1, be like this, 0, 1, right? 2, 3, 4, 5. So let's pick 5, and ideally we see this say 5 and 30. Look at that. It's 5 and 30. Okay. So already we have a way to dump just like raw data out to a binary file, which is exactly what we would be doing in JavaScript. So imagine that you're running this game on a browser. You have made some, maybe you've edited the game a little bit, which I'm going to be doing. I did it in the Zig version of this, which you can look back on. And you would like to save the data that you've edited. You're going to save it as a binary file. JavaScript lets you do that. It will read in to the WebAssembly memory block. It will extract a portion of memory as you so choose. It can then just dynamically create an href link and download, auto-initiate a download of a binary file. It converts it to a blob. Let me see if I can show you the example here. Here we go. So this is literally what it's doing. For example, so you'll extract memory, right? And you give it a starting point and the number of like how big the memory block is. And so you reach into the WASM memory, you grab the memory, you start at the memory location you've asked to pass in. You go up to the length. So it's starting location plus length, and that determines the full range of the memory you want to get. You pull it out in whatever style of memory you want. In the Zig case, we were using uint16 everywhere, so we're just going to use int32s moving forward. Then on the JavaScript side, it generates a blob, which is like a file data. And then, so you can see here, it's just a blob of file data, and it does an octet stream, which just means write me a binary file on the JavaScript side. We're not using JSON. We're using the blob, the octet stream. And then it creates an anchor tag, and it makes the href, the URL of it, as that blob gets put into like as if you were loading from an external URL. So just like URLifies the blob as a raw data file. And then it just initiates an automatic download by going click, as if you've clicked it, right? And so then we store a .bin file, and that's exactly what we're doing right now, except we're doing it on the WebAssembly side, and that's going to give us some flexibility so that we can do the following. Let's say that I want to move this over here. Let's do this, and we'll go files. Okay. And if I'm right, this should also just work, which it does. Because it just reads the whole thing. So that's great. So now we have a way to kind of offload our file management code into another file. And then we have a way also, if we really wanted to, we'll call it data. Sure, we'll call it data for now. And again, game ships array. Okay, so I guess the issue here is that files does not have access to game ships array. Yeah, which kind of makes sense, honestly. So what we could do, we maybe could take the main out of here. I'm gonna have to look this up. I'm not entirely sure how you would do it. Import. Okay. Core. Okay. Reference a package by different name. Yep. Exported names. Okay, all declarations in a package are exported by default. Private is equivalent to private. So shouldn't they just all share? I would imagine they would. How do they do it? How do they do it here? Well, here, let's go like this. All right. Foreign import, ODIN ENV. So not here. If we go to the example, No, it wouldn't be here either. I think it's where I'm putting the main file, but let's just see if we can, okay. So what if we did like, so there's time, right? And then if we go look at like time.js, yeah, okay. Linux. Yeah, all right. So I guess it's this main. It has to be out here. Everything gets loaded through here, I believe. And if that's the case, then I have to take these and bring them over here. Let's see if I'm right. Nope. OS. Because I need OS as well over here. Okay. And so it's still not reading the fact that I have data. Game ships array. Oh, I'm foolish. Bet you everybody watching is like, oh my goodness, it's because I named it bin. Yeah, there we go. Okay. So if I just, if I take this back, I wonder, I'm just curious if it's going to work. Here. Yeah, works. Perfect. Well, there you go. There you go. Mega Giga Chat developers like me can make mistakes. There's no hope for anyone, is there? Okay. That was actually not too bad. That's quite a bit done. In, let me see, in like 50 minutes. I thought that was going to take much longer. What it does mean as well is, well, okay, so now let me just try something here. So can we change, is this one of those things where you embed the file and it's statically embedded? You can't alter the data? Ideally, we can alter the data. Ideally, I can go into this value 30, change it to 33, write this again, and it'll say 30 and 33. And if that's true, well, that did something, but not what I expected it to do. All right. Yeah. Let me go see here. Maybe. Okay, let me just think about this for a second. Okay, we've loaded up. We've loaded up the game ships file. We've confirmed that it's printing out 30. Then we go and change the file, like the value, so that it's not 30 anymore, so that it's 33. And then we print out the value. So that should be right. I don't see why it would be wrong. Let's just see what happens if I, it is a touch slow, isn't it? Okay, I wonder what goes into what's in here. Is it 33? No. So it didn't actually change it then, did it? Let's be very specific. No, it still didn't change it. Let's be super sure, just in case. Yeah, it's the same thing. Okay, so it's probably got something to do with the bytes. So do we need to be converting these to the transmute is a bit cast conversion between two types of the same size. Okay. Maybe, okay, so I can either cast it or I can transmute it. So I would transmute what to like you know what I'm realizing? That maybe it's because of the way that we're doing load here. That we're pulling in. Okay, I'm gonna have to do some research on that and see if I can figure this out. It is a touch odd that it converts just fine. Like it reads the value just fine over here. You know, like I mean, I could just try it just for the sake of trying it. Yeah, it's not going to do it. I could do a value. Like this. Let's see what happens. That didn't do the trick either. Nope. It breaks right here. We can't seem to do that. So we probably have to do some kind of conversion. Yeah, so that it's not I'm just thinking in my head, so that it's like U8 or something. If we were specific about what it was, let's say we did like I32, just to be super specific. Could we do that? Cannot transmute V to I32, 8 versus 4 bytes. Yeah. So it is a byte issue. Okay, I'm going to have to sort that out. Essentially, the issue that we're running into is that the way that we're reading the file, the way that Odin reads the file, it sets the value, each value, to a specific integer type, and I just have to figure out what it is and then set it appropriately. So let me do something real quick. Over here. If I did a cast, would that work? No. Could I cast it as an int? It will break. Yeah. I'm just curious. Yeah, it breaks at exactly the same spot. Okay. All right. I think I'm gonna have to go look at yeah, there's an autocast. Yeah. I'm gonna have to go look at what it's gonna take to get this updated. I'm not really sure. I'm gonna have to ask around. So I'll do that offline. I'll figure it out. Yeah, but that's an interesting problem. Aside from this, though, essentially we have a working input-output binary file system. And so that means that I can go and make, any kind of array that I want in here. I can dump it out. I can bring it back in. I can hopefully I can adjust it. I bet I can. I bet it's just stored as memory embedded into the WebAssembly file, which then you can alter to your heart's content and then dump out a fresh copy and recompile it, which is perfect because then I can make all kinds of changes. So then I can start using the enums to do all kinds of stuff here. It gets really good. Yeah, it gets really good. I can preset a certain number of array values, like number of ships, and then just set the ship values or zero them out. Like there's a bunch of fancy stuff I can do now. And then I should be able to reach in and get ship data, or world data or layer data. So I can start implementing these. So that's probably what I'm going to do offline. I'll start implementing these functions. And then I'll get this to the point where I kind of have the structures and whatnot all built out. I'm going to do some ships. I'm going to do some maps. I'm going to do some layers. And once I have that and the ability for WebAssembly to give you the data you want on the JavaScript side, I'll build out the JavaScript side. It should be really easy. We're going to essentially do a lot of the stuff that we did with the Zig stuff. Just extracting memory out of WebAssembly and then rendering here with our assets. Then I can just start rendering the game. And then we're back to building the game and being able to play it, which is great. Okay, I think I'm going to end it there. It was a late night, no live stream session. That'd be fun to do. Yeah, have a good night. Have a good day wherever you are. I appreciate you watching. Peace out. So as it turns out, I was wrong when I ran into that issue with files being mutable versus immutable in ODIN or WebAssembly. Well, so essentially what was happening was I was trying to load a file in, and so like here, and then read from a particular index in the file, which is just an array, which we got to. We managed to do that. But when it came time to write to the file, I couldn't do that because technically you're not writing to a file. You're writing to an array that represents the file that you've loaded. The file is just an array. So I had to go do some digging, like I said, and I discovered that when you do load files in ODIN, they come in as immutable. When you load them into WebAssembly, though, they are mutable because WebAssembly is just a block of memory you can manipulate. So that's where it was throwing me off. I was trying to work within the confines of just regular ODIN and wondering why I couldn't make changes. Once I realized that it's just the difference between the way that ODIN and WebAssembly work with embedded files, then I got it to work. And if I can show you, yeah. So you can see here that these values are actually more representative of 32. The other issue was that I didn't realize until much later. You'll notice that before I used to have 1 and then 3 columns of zeros. Now I only have 1 column of 0. So it'd be 1 and then 10 and then 2 and then 10 and then 3 and then 30, etc. And so the reason for this is because when I was using int instead of i32 or U16 or whatever, Odin automatically takes whatever is available as part of your computer architecture. So in my case, it was doing 64 bits. When I explicitly defined 32, things started to work much better, and especially in WebAssembly, where at the most you're gonna be working in 32 bits. Well, at the very least, that's kind of the best way to work with it. Everything's kind of optimized at least at 32. So when you start playing with int and you're letting Odin and WebAssembly and the browser and all of that pick their bit sizes, then things start to get a little weird. If you're explicit and you say, okay, let's just do 32, then things start to fall into place much better. So I sorted those two things out. Okay, peace out.